Trigonometry, inverse trig functions. Trigonometry and calculators. We can use a calculator to find the value of a trig function, such as sine, cosine or tangent, for any valid angle. Note, tangent of 90 doesn't exist, so it is not a valid trig function. However, calculating inverse trig functions on a calculator will only give one value, when actually there are many possible values for an inverse trig function. For example, a calculator will give the sine of 150 degrees as 0.5. But if we reverse that and ask for the inverse sine of 0.5, the calculator doesn't give 150 degrees, it gives 30 degrees. Now this is because there are many values of the angle that have the same value of the sine. So sine 30, sine 150, sine 390, sine 510, sine of minus 210, sine of minus 330, sine of minus 570 degrees, and many more all have the value 0.5. So when using inverse sine 0.5, or sine minus 1 0.5 on a calculator, it always gives the answer 30 degrees. In fact, inverse sine always gives an answer between minus 90 and plus 90 degrees. The value it gives is called the principal value. If we use inverse sine on a calculator, it'll give an answer between minus 90 and plus 90 degrees. If we use inverse cosine on a calculator, it'll give an answer between 0 and 180 degrees. If we use inverse tan on a calculator, it always gives an answer between minus 90 and plus 90 degrees. So these are the principal values. Now, if we have a question, we can find the principal value using a calculator, but we may want one of the other solutions. So, to find these other solutions, one way of doing it is using a graph. Calculating inverse trig functions. Let's have a look at an example. Find the value of the inverse tangent of 1.2 for values between minus 180 degrees and 360 degrees. Well, to solve this, we first find the principal value using a calculator. So we type into the calculator the inverse tangent of 1.2 equals, and it gives the answer 50.2 when it's been rounded off to one decimal place. So we can then consider the graph. Now we have y equals 1.2, so we can draw a horizontal line y equals 1.2. Now, we know this intersects the graph at 50.2, and we can see that. But the line also crosses the graph at other points. One of those is 50.2 plus 180 degrees. Another is 50.2 plus 2 times 180 degrees. Another is 50.2 plus 3 times 180 degrees, and so on. Or 50.2 minus 180 degrees, and so on. Now, if we take those values which lie between minus 180 and 360 degrees, we get the answer. The inverse tan of 1.2 could be 50.2 degrees, or 230.2 degrees, or minus 129.8 degrees. Note, if the principal solution for x is the inverse tangent of y is x is equal to theta, then the general solution is x is equal to theta plus n times 180 degrees, where n can take any integer value. Now, let's have a look at another example. Solve the inverse cosine of minus 0.5 for angles between minus 180 and 360 degrees. Well, we can use our calculator to find the principal value by simply typing in inverse cosine of minus 0.5 and that gives 120 degrees. So if we draw the cosine graph and draw a horizontal line at y equals minus 0.5, we see the line crosses the curve at 120 degrees, but it also crosses the curve at 240 degrees, 480 degrees, and minus 120 degrees, and so on. So the values we want are theta is equal to minus 120 degrees, 120 degrees, or 240 degrees. So note, we can get a general solution. If the principal solution for x equals the inverse cosine of y is x equals theta, then the general solution is x is equal to plus or minus theta plus n times 360 degrees, where n is an integer. Let's look at a third example. Solve theta is the inverse sine of 0.8 for theta lying between minus 180 and 360 degrees. To solve this, we use our calculator to find the principal value. So we type in inverse sine of 0.8 equals, and that gives us 53.1 degrees when rounded off to one decimal place. Now we can draw the graph of y equals sine x. And we want the value of theta when y is equal to 0.8. So we draw a horizontal line at y equals 0.8, and we see that it crosses the curve at 53.1 degrees. But it also crosses the curve at 126.9 degrees, that is 180 degrees minus 53.1 degrees. It also crosses the curve at 413.1 degrees, and also at 486.9 degrees. So the values of theta we want are 53.1 degrees or 126.9 degrees. Now we can get a general formula for this. If the principal solution for x equals sine minus 1 of y is x equals theta, then x is equal to theta plus n times 360, or 180 minus theta plus n times 360 degrees for any integer value of n. It is worth remembering these three formulae, so let's highlight them, and we can use these to write down the general solution to an inverse trig question. So, the following are the general solutions when finding inverse trig functions for sine, cosine, or tangent. Case inverse sine. If the principal solution for x equals sine minus 1y is x equals theta, then the general solution is x equals theta plus n times 360, or 180 minus theta plus n times 360 for any integer value of n. For the inverse cosine, if the principal solution for x equals the inverse cosine of y is x is theta, then the general solution is x equals plus or minus theta plus n times 360 degrees, where n is an integer. For the inverse tangent, if the principal solution for x equals the inverse tangent of y is x equals theta, then the general solution is x equals theta plus n times 180 degrees, where n is any integer. Let's look at an example. Find the values of theta that satisfy the equation sine theta equals minus 0.5 for values of theta lying between minus 360 and 720 degrees. Well, to solve this, we've got sine of theta is equal to minus 0.5, which means theta is equal to the inverse sine of minus 0.5, And if we do this on a calculator, we get theta is equal to minus 30 degrees. So the general solution is x equals theta plus n times 360, or x is equal to 180 minus theta plus n times 360. So if the principal value is minus 30, we have x is minus 30 plus n times 360, or x is equal to 180 take away minus 30, which is 210, plus n times 360, for any integer value of n. So if we put in the value minus 1, we get x is equal to minus 30 minus 360, which is minus 390 degrees, and that's outside the range. Or n is equal to 210 minus 360, which is minus 150 degrees, which is inside the range. If we take n as 0, we get minus 30 plus 0, which is minus 30 degrees, which is inside the range, and we get 210 degrees plus 0, which is 210 degrees, which is also inside the range. If n is 1, then x is minus 30 plus 360, which is 330 degrees, which is inside the range, or 210 degrees plus 360 degrees, which is 570 degrees, which is also inside the range. If n is 2, then x is equal to minus 30 plus 720 degrees, which is 690 degrees, which is inside the range, or x is equal to 210 degrees plus 720 degrees, which is 930 degrees, which is outside the range. So the values of theta we want are minus 150 degrees, minus 30 degrees, 210 degrees, 330 degrees, 570 degrees, or 690 degrees. We can look at an alternative method of finding inverse trig functions. Suppose we want to solve cosine of theta is equal to minus 0.85 for theta lying between 0 and 360 degrees. Well, we can start by using a calculator. The cosine of theta is equal to minus 0.85, so theta is the inverse cosine of minus 0.85. However, we look up the inverse cosine of plus 0.85. We take the inverse cosine of the positive value. And on the calculator, this gives us 31.8 degrees when rounded off to one decimal place. Now, we draw a diagram. We start with the x and y axes, and we draw two diagonal straight lines intersecting each other at the origin. Now, we write 31.8 degrees just above the positive x-axis, just above the negative x-axis, just below the negative x-axis, and just below the positive x-axis. Then we write the letters A, C, T and S going clockwise around from the first quadrant. The word ACTS is an acronym for all, cosine, tangent and sine, and this tells us which quadrants are positive. So sine, cosine and tangent are all positive in the first quadrant. Going around, the quadrant labelled C is positive for cosine only. Quadrant T is positive for tangent only, and the quadrant S is positive for sine only. Now, we were told that cosine of theta was minus 0.85, so we want the parts that are negative for cosine. Well, A and C are positive for cosine, and so S and T are negative for cosine. That means we want the angles that are in the S and the T quadrants. Now, anticlockwise is the positive direction. And so going anti-clockwise up to the line, that's 180 minus 31.8 degrees, or 148.2 degrees, and going round to the line in the T quadrant, that's 180 plus 31.8 degrees, or 211.8 degrees. And so we have theta is 148.2 degrees, or theta is 211.8 degrees. Let's look at another example. Solve tangent of theta is 0.35 for theta lying between minus 180 degrees and 180 degrees. Now to solve this, we write down tangent of theta is 0.35. And we use the calculator to find the inverse tangent of 0.35. And the calculator gives us 19.3 degrees when rounded to one decimal place. Now we draw the diagram, the x and y axes and two lines going across through the origin, and label them ACTS. Above the x-axis we write 19.3 degrees, and we do the same above the negative x-axis, below the negative x-axis, and below the positive x-axis. Now we want the quadrants that are positive for tangent. That's A, because all of them are positive, and T, because tangent alone is positive. So we want to read off the angles for those two lines. Now going anti-clockwise, we can go 19.3 degrees, or going clockwise, we can go minus 180 minus 19.3 degrees, and this gives us minus 160.7 degrees. So we have theta is 19.3 degrees, or theta is equal to minus 160.7 degrees.